Today's lesson is on congruent figures, and more specifically we're going to focus on congruent triangles. So a good essential question would be, what are congruent figures? And how can I determine if figures are congruent? All right, so what does it mean for figures to be congruent? It just means that they have exactly the same size and shape. So two geometric shapes are congruent if they have exactly the same size and shape. Now that's not to say they can't be rotated or translated, but they have to have exactly the same size and shape to be congruent. Congruent polygons have congruent corresponding parts. That is, their matching sides and angles. When you name congruent polygons, you must list corresponding vertices in the same order. So let's take a look at how that looks. All right, so right here, if we have this quadrilateral ABCD, and we tell you that it is congruent to quadrilateral EFGH, then right here we've listed all the corresponding congruent sides, and here we've listed all the congruent corresponding angles. So let's look at these triangles here and make sure that we can name them in the correct order. All right, let's start with naming the congruent corresponding sides. What about AC? We know that AC is going to be congruent to RP because they have the same markings. We know that AB is congruent to the one with 3 marks, which is OP, or is that Q? That's a Q. That's a Q right there, I think. So QP. And we know that, let's see, we have AC, AB, so how about BC? BC is congruent to OR. Now let me make sure I have these listed in the right order. I want to go from the corresponding vertex to the other corresponding vertex. So if I've listed AC, I need to say that AC is, I need to start with this same angle, so I really should call this PR instead of RP. So we got to make sure we got things in the right order. I just did it again, didn't I? AC, yeah, I wrote it just like it was, PR. Come on, guys. PR. It's a Friday afternoon. I'm trying to rush out of here. Probably going to make a lot of mistakes. All right, how about AB? Once again, starting from this angle going to the one with the 2 markings, so I should call that PQ. So yep, I did that one backwards too. So that should be PQ. And then finally, what did we say? BC. So BC from this vertex to this one would be QR. Maybe I had that one right. I don't know, but yes, order does matter. Okay, let's name the congruent angles. Angle A is congruent to angle P. Angle B is congruent to angle Q. And angle R is congruent to angle C. And now we need to write a congruent statement regarding these triangles. So let's start with triangle ABC. And we're going to say that is congruent to PQR. PQR. Order does matter. The corresponding vertices have to be in the same order. All right, how about here? We've got quadrilaterals, and we know that DEFG is congruent to KLMN. And they are not situated the same, but that's okay because we know which parts are corresponding because of the way they're listed. All right, so let's see, we're trying to find the value of x. Here's x on this side mn, so let's start with that. Let's figure out mn. Let's figure out what mn is congruent to, and maybe it has a number on it here. mn, here's mn. If I look at my letters, mn is going to be congruent to fg. I just have to look at the order that they are listed in. So that means these two would be equal, their measures would. So 5x plus 2 is going to equal 12. So 5x is 10, so that gives me x is 2. And then if I want to find y, I got to figure out what angle is congruent to L. So angle L would be congruent to angle E. Angle L's measure is 5y plus 6. Angle E's measure is 111. I'm sorry, 111. Therefore, 5y equals 105, meaning that y would have to be 21. So that's all we have to do to solve these kinds of problems. Order does matter. Be very careful. All right, are the triangles congruent? Well, how do we know if they're congruent? If all the corresponding angles and sides are congruent, then we know the triangles are congruent. So let's see what we have here. We have this is congruent to this. This is congruent to this. This side is congruent to this side. Then we got the angles, A and E. We got B and D. And what we don't have is our third set of angles, but hey, what do we know about these? We know they're congruent, don't they, because of the vertical angles theorem. So yes, indeed, these triangles are congruent, and let's write a congruent statement for the practice. Let's say that triangle ABC is congruent to triangle EDC, right? And let's make sure, is side AB the one that's congruent to ED? AB, ED, yes it is. And we could go through this whole set of corresponding parts and make sure that we have labeled our triangles properly in that congruent statement. All right. Recall the triangle angle sum theorem. The sum of the measures of the angles in a triangle is 180 degrees. We have a corollary and a theorem, and I don't know if I've ever really told you, but a corollary is another theorem, and it's easily proven using another theorem. So a corollary is really nothing different from a theorem. You can use corollaries as reasons in proofs, and we will do that quite a bit. So let's look at the corollary to the triangle sum theorem, triangle angle sum theorem, right there. And what does it say? It just says the acute angles of a right triangle are complementary. So the measure of angle A plus the measure of angle B has to be 90 degrees. And if you think about that for just a second, it makes perfect sense because you know the sum of those angles is 180. If one of them is 90, the sum of the other two has to also be 90. All right, and then we have another new theorem. It's called the third angles theorem. And it states that if two angles of one triangle are congruent to two angles of another triangle, then the third angles are also congruent. So if angle B is congruent to angle E and angle A is congruent to angle D, then I know by this theorem that angle C is congruent to angle F. That's all the third angles theorem says. All right, now we have some congruence properties of triangles, just like we had for angles and segments. Every triangle is congruent to itself. We know that because of the reflexive property of congruent triangles. We know that if triangle ABC is congruent to triangle DEF, then triangle DEF is congruent to triangle ABC. And of course, that's a symmetric property of congruent triangles. And finally, if triangle ABC is congruent to triangle DEF, and triangle DEF is congruent to triangle JKL, then by the transitive property, of course, we can say that triangle ABC is congruent to triangle JKL. All right. Let's do just a couple of practice problems and then we will be done with this lesson on congruent figures. Let's determine if these triangles are congruent and we will need to justify our reasoning. All right, well, we need to make sure that all the corresponding parts are congruent, right? So we've got an 81-degree angle, an 81-degree angle. We've got a side, that side. We've got this side and this side. This side and this side, and let's see. Of course, I know that these two angles are congruent because they're vertical angles. I don't. What about angles E and G? Oh yeah, thank goodness for that new theorem I just learned, right? Because it tells me that since the other two angles of the triangles are congruent, the other two pairs, then I know that those two angles are congruent. So yes, these triangles are congruent. And our reasoning would be, by the third angles theorem, angle E is congruent to angle G. And of course, if I were doing this as a two-column proof, before that step, I would have had to have stated that my vertical angles are congruent by the vertical angles theorem, but I'm not doing a proof, so I sort of shortcut that there. All right, so now that I've got that, I'm going to write my congruent statement, and I'm going to say that triangle DEF is congruent to HGF, triangle HGF. If you want to pause here and make sure that our corresponding parts are matching up in the way we've written that congruent statement, then by all means do that. All right, you've really just got 3 more problems here, so as usual, I want you to pause and try to work these problems. Come back and I'll have the solutions on the board for you. All right, here's what I got for the answers. Please check these. I got x equals 10 on this problem right here. For this problem, I got x equals 16. And down here, I said, yes, they are congruent. By the third angles theorem, I know that angle Z is congruent to angle F, and therefore all the corresponding parts are congruent. I wrote my congruent statement. If you missed any of this or have any questions about this, please take a note on the side of your paper here so that we can talk about it at the beginning of class tomorrow. Write your summary, and we'll see you next time.